There are two problems you should know how to do in level 4 for this skill. And they are both problems you've seen before. One is finding the shortest distance from a point to a curve, and the other is finding the maximum area of a rectangle bounded by a graph and the axes in the coordinate plane. And I'll show you how to do that one too, even though it's not in the notes packet. So the first problem, finding the shortest distance from a point to a curve, first you need to figure out what the graph looks like, and you do have a calculator so you can use it if you need to, but we should know what natural log of x minus 1 looks like. It's just our natural log graph shifted 1 to the right. So it looks something like that. And the point negative 1, 1 is somewhere over here. And we want the shortest distance from that point to the graph. And on this graph, we don't know what that point would be. It's some mystery point, some xy pair. And so what we're going to do is write a distance function that we are going to try and minimize. The distance formula for 2 points is the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. And so we're going to take our 2 points and plug them into the distance formula, but we don't want to have two variables. We only want one variable, so we need to replace that y with an expression for y in terms of x. And since that unknown point is somewhere on the graph of the natural log of x minus 1, we can replace y with the expression natural log of x minus 1. So I'm going to erase the y, and instead I'm going to call y natural log of x minus 1. And now I'm going to plug these in my distance formula. So this is going to be my x1, y1, and my x2, y2. So we get distance equals the square root of x minus negative 1, you can change that to x plus 1 if you want, quantity squared plus, for y1, natural log of x minus 1, close the parenthesis, minus 1, quantity squared. Side note, you cannot combine the minus 1 inside the natural log with the minus 1 outside. You can't combine a number inside a log with a number outside. So we just leave that like that, and you plug it in your calculator. So we turn on the calculator, go to graph, and I'm going to clear what's in here already. And so I put in my distance formula. Move this over. So we go to tab, and in F1 I do a square root and then a parenthesis. You can do x minus negative 1 or change it to x plus 1. Calculator doesn't care. Quantity squared plus parenthesis natural log, so I do control and then that e to the x button for natural log, and then inside natural log x minus 1, get outside of that parenthesis and another minus 1, and outside of that parenthesis square it. Hit enter, and this graph represents the distance from the point negative 1, 1 to any point on that graph natural log of x minus 1. If I want the shortest distance, I need to find the minimum point of this graph. So I go to Menu, Analyze Graph, and Minimum. When it says lower bound, I need to move to the left of the minimum point. And then for upper bound, I move to the right of the minimum point. And I'm going to hover over that point and hold down my middle button to pinch it and move it so I can read it. And you can move your function out of the way too if you want. Okay, so the minimum point of the distance graph, so if this is our distance graph, D, the minimum point is 1.59, 3.01 approximately. So the shortest distance is going to be that y value, since this graph represents distance. The shortest distance is 3.01. The other part of this is the closest point on the graph, that unknown xy pair. What are the coordinates of that point? And to figure that out, the x value on our distance graph came from the x on our original graph. So it's the same x value. So that is the x value of our unknown point. To find the y value, we're going to plug that x value into the graph natural log of x minus 1. So y is going to be natural log of 1.59 minus 1. And we can calculate that. So go to your calculate screen and do natural log of 1.59 minus 1, and you get about negative 0.53. So the closest point is, the coordinates are 1.59 and negative 0.53. That's our unknown point on the graph that's closest to the point negative 1, 1. The next problem, this one's not in the notes, this is actually the last problem from the packet, is being able to find the maximum area of a rectangle bounded by a graph and the axes. So in this problem, it's a little bit of a twist on our normal question in this format. This rectangle is bounded by the negative x-axis, the positive y-axis, and the curve. So usually we've seen it in the first quadrant, now we're in the second quadrant, so it's a little different. But we've got a point on the graph, a point on the x-axis, a point on the y-axis, a point at the origin, and that makes a rectangle. And we're trying to find an equation for the area of this rectangle so that we can then maximize that area. The area of a rectangle is always an x value times a y value, because the x value here multiplied by the y value here is the length times width of the rectangle. Now in this problem, the x values are negative because we are on the negative y or x-axis. And so if I multiplied a negative x value by a positive y value, I'll get a negative area. And there's no such thing as a negative area. So to counteract that negative, I'm going to put a negative sign in front of my x. So the other thing I want to do is write this formula in terms of x. So I'm going to keep a negative sign in front of the x to counteract the fact that the x values are negative. But then I need to replace y with an expression for y in terms of x. Since this point is some xy pair on the graph of y equals 4 minus 3e to the negative x minus 5, I can replace y with the expression 4 minus 3 to the negative x minus 5. So instead of y, I put 4 minus 3e to the negative x minus 5. That's an expression for y in terms of x. And this is my area function for the area of that rectangle. And so we graph it. So we go to graph. Again, I need to delete my last problem. And I hit tab and enter my area function, which is negative x times parenthesis 4 minus 3 e to the negative x minus 5. And enter. And so we get a graph this time. The graph is in quadrant 2, and the maximum point of that graph is what we need. So we go menu, analyze graph, maximum. We move to the left of the maximum point, click, move to the right of the maximum point, click, and you get the maximum point. And that point is negative 3.73, 11.78. So the maximum area of this rectangle, since remember this is our area graph, the maximum area will be 11.78. Now, if we needed to know the dimensions of the rectangle with the greatest area, the x value right here came from here. So the x coordinate is negative 3.73, and to figure out the y coordinate that goes with it, we can plug that x into the graph, our original graph, y equals 4 minus 3e to the negative x minus 5. So for the y coordinate, we do 4 minus 3e to the negative, and then I plug in negative 3.73 minus 5. And we plug that in our calculator. So we go to the calculate window. 4 minus 3 e to the, now there's a negative sign and then a parenthesis. I'm plugging in my negative x value, negative 3.73, and then I subtract 5, still in the exponent. Enter, and we get about 3.16. Okay, now we had a negative x value for this point, but the dimensions of a rectangle should be positive numbers, because there's no such thing as negative lengths when we're talking about a geometric figure. So the dimensions of the rectangle are going to be 3.73 by 3.16. There you go.